There are y black and 5 white socks in a drawer. I instantly draw the drawer to help me out, and I'll write the fact that we've got y black socks and 5 white socks. I'm not very good at drawing, as you can see, and I like to write there's a total of y plus 5. Joshua takes at random 2 socks from the drawer. The probability. Now, probability suggests I'm either going to be using tree diagram or Venn diagram or sample space, and I think this is a probability tree. We've got to take 1 white sock and 1 black sock. But of course, there's a different way we could take 1 white and 1 black. We could take the black sock first and the white sock afterwards. Now, the chances the first one we take a white, if we look to the drawer, is 5 over y plus 5. If I take a white sock, there's still y black socks in the drawer, but there's 1 less sock in the drawer, so it's not over y plus 5, it'll be over y plus 4. The probability the first sock I take is black is y over y plus 5, and if I take a black sock, doesn't affect the number of white socks, there's still 5 of those, over y plus, I've taken a sock, so 4. And as we know, as we go across the page, we write across. So I've got to do 5 times y, 5y, over y plus 5 times y plus 4, y plus 5 times y plus 4 gives me y squared plus 5y plus for the 4y, 4 times 5 is plus 20, so it's y squared plus 9y plus 20. And the same for the bottom one. Y times 5 is 5y over y plus 5 times y plus 4, same sum, y squared plus 9y plus 20. As we go across the page we times, and as we go down the page we add, and quite nicely these are the same. So 5y add 5y, we get 10y over, please don't add the bottom fractions together, it's still y squared plus 9y plus 20. Now, looking at the question, it says the probability Joshua takes 1 white sock and 1 black sock, which we've just done there, is 6 over 11. The 2 awkward things here are that bit there and that bit there. Nobody likes dividing, so we'll move them both. They were dividing, they'll become a times. 10y times 11, we've got 110y equals 6 times y squared, 6y squared, 6 times plus 9y, we've got 54y, and 6 times positive 20 plus 120. Are we getting anywhere? Well, it's wanting it equal to 0, so let's move this positive 110y over. 0 equals 6y squared. 54 minus the 110y is minus 56y plus 120. Which is a bit awkward until we realise, hang on, that's just half of this. So if I divide the left hand side by 2 and the right hand side by 2, we get 0 equals 3y squared minus 28y, half of 56, plus 60. That's quite easily done. Which stands for quod erat demonstrandum, whenever you've proved something. Part B, find the probability that Joshua takes 2 black socks. Well, we've got a lovely quadratic here. We've got to solve it. Menu. A. 2. 2. We've got 3 equals, minus 28 equals, 60 equals. We know either y is, if I press equals on the calculator again, y is 6 or y is 10 thirds. Now I don't know about you, but I find it quite difficult to have 10/3 of a black sock, so quite clearly that one doesn't work. We know y is 6. We know we've got 6 black socks, 5 white socks, 11 in total. What's the probability that Joshua takes 2 black socks? Probability? Probability tree. The world's easiest probability tree, because he's got to take a black sock followed by a black sock. The probability the first one we take is black, 6/11. If I've taken a black sock, it does affect how many there's left in the drawer. There's only 5 of them, and there's only 10 of them left in the drawer. As I go across the page, I'll draw a cross. 6 times 5 is 30. 11 times 10, 110. Didn't ask me to simplify, so I'm quite happy with my answer.